Hello everybody and welcome back. In this video we're just going to do a random calculus problem. We're going to tackle the integral of ln x squared dx. So I'm going to approach it a little bit different than most people. A lot of people would approach this with integration by parts. I'm going to use u substitution. So I'm just going to use the kind of canonical u substitution here. Let's just let u equal ln of x and see what happens. Well, if we take du, we get 1 over x dx. But we want to get this thing all in terms of u now. So I get the integral of ln x, that's just u, right? So that's u squared. And now dx, let's solve for that. Dx, if we solve for dx in this equation, we get dx is equal to x du, right? But again, we want it only in terms of u, so we need to know what x is. Well, we can solve for what x is in the first equation right here. So if we take e to both sides, we get e to the u is equal to x. So this is key right here. We're going to use that in place of x down here. So now we're going to write e to the u du is dx. Good. So now we're strictly in terms of u. So now dx is e to the u du. Let's write that here. I forgot my e to the u. Whoops. E to the u du. Alright, I'm going to pan out a little bit. Now below, we want to calculate this integral now, which is actually a fairly easy integral. You can do it by parts, which is kind of funny because you could have approached the original problem by parts. But anyway, if we approach this by parts, or if we use the tabular method, which I'm going to elect to use the tabular method, so I'll just type via the tabular method. We can write u squared in the d column and then write e to the u in the I column. So we have di, we're differentiating down to 0 in this column, and then we're integrating repeatedly in the right hand column. I'll pan down just a bit. So we differentiate, we get, we get 2u, we get 2, and we get 0. And then if we just keep integrating e to the u, the integral of e to the u is just e to the u. So this is the tabular method of integrating. It's equivalent to integration by parts. So we can draw in these down diagonals, and we stop here at 0. We don't draw a down diagonal for 0 because then it'd just be 0 times something. But anyway, we go plus, minus, plus. We alternate signs here, and then we just consider what this sum of products is. So we get, so this right here, this integral above, u squared e to the u du, that just becomes u squared e to the u minus 2u e to the u plus 2 e to the u. Okay, I'm going to pan up a little bit just to take note of something. Remember that e to the u is x, right? So that means we can just write e to the u as x, and then each of these u's, panning up a little bit further, each of these u's down here is just ln x. So we just write the u's as ln x, we write the e to the u's as x, and then we're basically done. Now we just got to remember our integration constant. So we just write ln x squared times x minus 2 ln x times x. Maybe I'll just insert some parentheses just to make sure no one confuses this. And then plus 2x plus c. If you would like, you can check that if you take this answer and you differentiate it, you do get the ln of x squared. So just know that's a good way to check your answer when you're integrating. That's the end of this video. Please stay tuned for more videos, and we'll see you in the next one.